Kia ora team, this is Mr. Dharma. Today I'm going to talk to you about definite integrals. So, before I do definite integrals, let's quickly talk about some notation that we can use in integration. So, first off, if I have dy by dx is equal to 2x plus 7, we might want to formalize a way of saying y equals something before we actually do the integration. And so how we do that is we write y is equal to the integral. The symbol is a long S looking symbol. The integral of 2x plus 7, typically put that in brackets, dx. And how we read this is y is equal to the integral of 2x plus 7 with respect to x. And so the operation is simple. It's add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and plus c. So we have integrated. That is integration, and this is the integration notation. There is not a formal notation for what integration is, but I like to write capital F. So if I have capital F, it's typically the integrated version of little f. So if you were to use functional notation, if f of x was equal to 3x minus 1, or 3x plus 1 rather, then I'd say capital F is equal to the integral of dx, making sure I put brackets. As you get used to the maths, you tend to skip those brackets, but it's kind of really important because calculators tend to mess this up quite a lot. Alright, so that's how we integrate, and we can integrate all of these functions. Now that we've got this notation, we can do some fairly funky stuff. Integration is actually a representation of the area underneath a function. So if I gave you f of x was this line that I've drawn, then the integral of f of x is the area underneath this function. And that is kind of really special. And we're going to have a look at that through a really nice example. So consider y equals x is a wonderful function. Wonderful drawing from me as well. So here we go. F of x is equal to x. And so let's find this integral and see what it actually is and see if we can make a sense of it. Alright, so the integral of f of x dx is the integral of x dx. And what's the integral of x with respect to x? That is add 1 to the power, divide by the new power, plus c. And so, if you kind of look, and you look, the distance from here to here is x, the distance from here to here is x, half x squared is the area under that curve, which is pretty exciting, because even if this wasn't a nice function, you'd still get the area. I know some of you are asking, what does this plus c have to do? We'll have a chat about plus c a little later, okay? But let's try to find the area of something else. Well, the integral of sine x is negative cosine x plus c. Now I've used formal notation here. I can just say integrate, and that's really exciting. So, where to from here? Well, this new notation gives us an opportunity to do something fairly cool. I could ask for the integral of x from 0 to 5. And that, if we look at this picture, is saying, what's the area from 0 to 5? And if this was a triangle, we could work it out, because this side would be 5. That's 5. 5 times 5 is 25, divided by 2 is 25 on 2. But let's see if we can work this out using integration. So we add 1 to the power, divide by the new power, plus c, always plus c. And then what we do is we write this. We say we're integrating from 0 to 5. Now what we do is we substitute. We substitute 5 first into x, and then we substitute 0 in for x. Okay, remembering to carry the c. Then we get 25 on 2 plus c minus 0 over 2 minus c. If you kind of see, get it? The c and the c cancel. And because of that, I'm sort of left with 25 on 2 is my area. And the c disappears. And so, what I've just done is called a definite integral. What I'd done up to here was indefinite integrals. Let me label that. This is an indefinite integral. And this is a definite integral. And so, a definite integral always has the c's cancelling. And this is wonderful, because now, if I were to go through this working, so suppose here's another question, from 2 to 4 of 2x plus 7 of dx, I can just integrate this. Add 1 to the power, divide by the new power, add 1 to the power, substitute 4, 2, and we go plug in the 4 first, plug in the 4, and that c that we've always had, because we're doing definite integrals, we can actually just not write it because we know it will cancel. 4 squared 16, 7 times 4 is 28, so we have plus 16 plus 28 minus 4 minus 14. So that's, if you work this out, you will get 26. Check my maths for me, it might not be right. But this is called definite integration. So this finds the area between the line and the x-axis. So here's a picture for this one here. So this is y equals 2x plus 7, so it's a line that's kind of steep, and it crosses up at 7. So this is at 7, and it's got a gradient of 2, and I'm working it from 2 to 4. And so in fact, it's this area in here, where this is f of x is equal to 2x plus 7. It is a trapezium, but the thing is, it's probably easier to work out the area using integration than to try and find two trapezia. And that's what's really exciting. Instead of finding the area of trapeziums, you just find the area using integration. And now, even if I made the function crazier, like I'll find the definite integral from 0 to pi on 2 of sine of x dx, we will get sine integrates to negative cosine, and then pi on 2, 0, and so we sub the pi on 2 in first, so that's cosine pi on 2 minus negative cosine of 0. Sorry, let me write that bracket nicer. So cosine of pi on 2 is 0, so negative 0 minus, well, cos of 0 is 1. And so we get negative 0 plus 1 is 1. And so the integral is this area here. I'm going to rough sketch it. Please don't laugh at my drawing. It's a cosine curve. It's a, sine curve. Okay, and we're just looking at from 0 to pi on 2. And apparently, this area in here is 1, exactly. Which is kind of crazy. So, from definite integrals, what we can do is we can actually talk about this. So what if I were to integrate sine from 0 to 2 pi? What do you think would happen? Well, we know the integral of sine is negative cosine, but we'd have to substitute from 0 to 2 pi. But before we have a work out, let's have a look at this. We have the area of that and an area down here. Let's see if we get something. Also, this has an area of 1. This probably has an area of 1. This has an area of 1. This has an area of 1. So what I'm expecting is 4. Let's see if we get 4. So we sub in negative 2 pi, or plug in 2 pi. And we plug in cosine of 0. And what we get is negative 1 minus minus 1, which is 0, which is not 4. And so this is a huge disappointment for us. But that's only because what's happening is, in this integration, we get the area between the x-axis and the curve. Okay, and if it's above the axis, like this will be a positive area. And if it's below the x-axis, like this, it will be a negative area. And they cancel out. And so that's why we got 0. So if we did want the area between this curve and the x-axis, and we wanted that answer of 4, what we need to do is we need to change this integral into 2 integrals. One from 0 to pi of sine of x dx, and then we need another from pi to 2 pi of sine of x. But we know that this second integral is going to be negative, so we take the absolute value of it. Okay, let's try work this out. Sine integrates to negative cosine. We know that, tried and true, from 0 to pi. And then we get the absolute value of negative cosine x from pi to 2 pi. And let's plug in all of these numbers and see. And I'm just going to make this section, all green, so you can tell that we're going to have some weird negatives that we're going to deal with. Alright? So here we go. So let's substitute negative cosine of pi minus negative cosine of 0 plus the absolute value of the negative cosine of 2 pi, always plugging in the first one first, the top one first, minus negative cosine of pi, and once again absolute value. Let's work these out individually. So I would encourage you to remember these ones, but cosine of pi is negative 1, so this is negative 1 minus, what is cosine of 0? Cosine of 0 is 1, so negative 1, because there's a negative there, plus Well, we've got the absolute value bar. Cosine of 2 pi is 1, but there's a negative in front of it, so negative 1 minus cosine of pi is negative 1. So that's, and once again, we're taking the absolute value. So let's work this out slowly. Right, you've got to be very careful with your negatives. Negative 1 is 1, minus 1 is plus 1, plus, once again, absolute values, negative 1, minus, 3 minuses make a minus. So we get 2 plus minus 2. But that's absolute valued, so we get 2 plus 2 is 4. And once again, we get the answer we were expecting from the picture above. But look at the two different integrals. This first one, we did from 0 to 2 pi, and unfortunately, because there were negative areas and positive areas, we weren't able to get 4. But when we wanted positive areas, we had to split the integral into multiple parts. Okay, I hope this helped. I'd really look through this again with a fine-tooth comb and check what's happening, and we'll have more of a chat in our tutorials. Thank you. I'll see you next time. Bye for now.